So folks, in this video, I will attempt to talk about MPLS segment routing and kind of sort of talk about the differences, when to use which one, what are they, stuff like that. So, I don't know why this guy is always sticking. Okay. So let's talk about routing to begin with, just to kind of recap. So we're going to talk about basic routing first, just to get an idea, context, perspective. And we're going to talk about MPLS. And then we're going to talk about segment routing and perhaps traffic engineering. Now, routing is a very generic concept, right? And then the basic concept here is that you have routers with networks, stub, transit, another router, 1 and 2, and another stub. So if this guy is N2, network 2, and this guy is N1, for this router 1, to know about N2, you got to put in a static route and tell him, hey, if you want to go to N2, your next hop, keyword is next hop, which is going to be an IP address, is going to be this. So you're telling this router that to go to N2, your next hop is this. And so when the packet comes, says, I want to go to N2, the static route says, go to the next hop. And this guy says, oh yeah, it's a connected network. If you're not working with statics, you use dynamic like OSPF. I wouldn't go to RIP, but RIP also does that, but RIP is pretty much obsolete. ISIS, BGP, these are considered dynamic. BGP is more static, I would say. But anyway, you can call it dynamic when you configure it like that. But OSPF, ISIS, if you enable OSPF, let's say here, it would, you enable OSPF on this one, this one, this one, OSPF will start advertising saying, hey, this router is going to advertise N1 to N2 to router 2, and the router 2 is going to advertise N2 to router 1, and that's how they learn. So that's dynamically advertising, and static, you start defining static routes. But that's just routing 101. All right, so where does MPLS come in? So the MPLS is, instead of next hop being an IP address, it's a label. It's just a label, like a tag. Call it whatever you want. It's not an IP address. So it's just a label, tag. It used to be called tag switching, and the purpose for that was to speed up lookups. Then it evolved into label switching. So now the thing is, okay, we're using labels and not IP addresses for next hop is always going to be there, right? But now we're using IP address labels / tags for next hops, not IP address. So that's MPLS. How do I distribute these tags? How do I know that an IP address is this label? Label 1, one IP address, second IP address, prefixes, is label 2, label 1, label 2, so on and so forth. So a bunch of IP addresses or network addresses basically mapping to a label or a tag, like 1 or 2 or 16 or whatever, right? That you get the idea. It's just a simple integer instead of an IP address. So that's MPLS, right? And MPLS is always, pretty much always used in the core network. And like I said, initially it was designed to speed up so that the routers could look up labels instead of IP addresses, but its use cases has now pretty much been VPNs, MPLS VPNs, right? So this is a simple routing topology. If we were to redraw this for MPLS, you would say, okay, here's a CE router connected to a PE router, and that's a P router, and then another PE router, and another CE router, and that's like customer edge, provider router, provider edge. And so this is the MPLS VPN topology where the customer edge advertises their prefixes in whichever way or format, usually BGP, could be statics, but it's either going to be BGP or statics, into the provider or the core network. The core network could be owned by the company or it could be an enterprise. So this is your BGP, right? And it's running protocols like OSPF inside here or ISIS. And the customer also has its own protocol running inside its network or static. So all these networks are coming to this guy. He knows about all the networks behind him. And this is like site 1, Los Angeles. He wants to advertise these networks to his other site, New York. And he's doing the same thing. He's advertising his networks to LA. So now his networks are all like 10, 1, blah, blah, blah. And this is 10, 2, blah, blah, blah. Right? And they're learning so that they can route. Now, obviously, this is customer routes, right? Customer routes. And they cannot be flooded into the provider or into the core unnecessarily. You don't need to, otherwise you'll have like service providers will have multiple customers, and there would be overlapping of these. So there's no way you can do overlapping routing in the core. So that's where the VPNs come in, or /VRFs. So this guy is going to take in all the routes into a VRF. He doesn't have to run a VRF. Could, but doesn't have to. He takes this PE router interface is on a VRF customer 1. Same here. And he's got multiple customers with different VRFs. Then he puts the VRF into a label, maps it to a label, right? And then he advertises that label to this guy through BGP. And or he advertises the label / the IP address prefixes, the networks. And then he says that, hey, this loopback address of this PE is mapping. If you want to come to this network 1, let's just say this is network 1, network 2. If you want to come to network 1, here, use label 1. And therefore now, and this network 1 is a VPN label. So he uses this loopback address for P, saying, okay, if you want to come to loopback address of PE1, PE2, and I'm oversimplifying, use label 11. So now he passes this label to the P passes this to, now he knows now to get to N1, he's got to use label 11. So now their next hop is labels. This guy never knows 10.11, 10.22, whatever private customer. He only knows labels. So his routing table only has loopback addresses of PEs, Ps, and that's it. All he needs to do is transport a packet coming from here that has got the network in a tag, which is basically a VPN, and he needs to know how to get to the edge so that he can decapsulate it and pass it on. That's the high-level concept, and I'm not going to dig into the step-by-step process. You have tons of documentations and videos out there, but moving forward, that's how VPNs work, and that's how labels are getting distributed. When I say distributed, you got to use another protocol called LDP. So that's one way. So label distribution now, you got to have a way to distribute these labels. So label distribution can be done by a protocol called LDP. You can run LDP here, here, here on per interface basis. They'll establish a neighbor relationship and start distributing labels, saying, hey, my labels for this guy is this. And that's how the label stack gets developed. Loopback label, customer label, VPN label, interface label, blah, blah, blah. So now your next hops are labels instead of IP address. You got to use a protocol called LDP. The other way is you use an IGP that supports label distribution like OSPF/ISIS. So you don't want to use this guy because you're already using OSPF/ISIS to route or advertise your loopbacks. So why not use the same one to distribute the labels? So get rid of LDP, use this guy. And I think the LSA for that is LSA 8 or something. So they use one of the LSAs to distribute the labels. Opaque LSA, I think it's called. I always forget the numbers. But anyway, so opaque LSA, they use the IGP. Bottom line is they now use the IGP, OSPF ISIS, to distribute the labels, label distribution instead of LDP, which is yet another protocol. So let's eliminate LDP, use ISIS, OSPF to distribute the protocols, and you're still getting next hop as labels. Now, okay, so sounds good. All right, now what's another problem here? Now you got each router with a table. So here, if you put in co-routers, blah, 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 every router is going to have a routing table. And that routing table can be big or small, depending on the network size. But obviously, these technologies, MPLS, VPNs, segment routing, traffic engineering, this is like service provider / large enterprises, very large enterprises. Very large enterprises that are using these scalable. So the bottom line is these technologies are scalable. You are going for scalability because you got a big, huge core. So if you have a big, huge core and then your routers are just having a routing table / label table that is hundreds or thousands of information line after line, your router needs to have a lot of CPU, a lot of memory, which is not an issue nowadays, but it still work. So whatever you have, however powerful memory CPU you have, crunching a lot of information is still work. And the networks are just getting bigger and bigger. I think the internet table today is close to a million, I think, million routes. But anyway, so how do we solve that problem? Which is basically your every router is maintaining. So you not have only one P routers, you've got hundreds, maybe thousands of P routers. How do you solve that huge label distribution tables, routing tables, blah, blah, blah? You move to segment routing. So what is segment routing solving for you? So now what you're saying, okay, I don't wanna maintain label tables or state information for labels. I want the guy who's sending the packet, like for this guy, it's going to be PE. He's going to tell me all the routes. So it's basically segment routing is source routing, meaning the source is going to tell me what the route is instead of me maintaining the table of next hop. So he's going to tell me where to go, and I'm just going to send him, I'm just going to forward the packet. That simplifies your state information, your tables. That is pretty much, now you're using CPU memory to maybe do something else like forwarding much quicker and converging much quicker and a lot of stuff, but you don't have to maintain large tables for labels anymore because you're using labels to forward. So now your source router or the packet coming has all the information to tell you where to go on top of, the IGP table. So now you're simplified. So segment routing is essentially running right here in the core between PEs and PE routers. And the PEs are basically putting all the labels ahead of time and saying, you go here. And then he says, okay, after what's the next label? So again, next hop, next label, looks up the next label and forwards. For this label, I'm going this way or that way, whichever way. So it's basically source-based routing. So now, let me fix this. So now, what's happening is you have simplified the problem of maintaining the state tables, label tables by segment routing. So segment routing is essentially compared to traditional MPLS, which uses LDP to distribute protocols or IGP, but MPLS traditionally uses tables to maintaining tables to forward the packet. Now segment routing is compared to MPLS, it's still MPLS, but it's source-based routing again. So you don't have to maintain all that, right? And then traffic engineering, you can also tell from the source where to go, what's the next hop. It could be logically from a metric perspective. You have a voice traffic that goes this way, you've got a data traffic that goes the other way, you've got to have multiple paths that you cannot depend on label switching / IGP to determine where the traffic needs to go. So you implement traffic engineering, which you can do with MPLS LDP as well, but segment routing enables more scalable. Again, the key thing is now you're getting into more scalable, and then you have application controllers that you can use now to say if the label for the traffic, for this traffic, take this path, for this traffic, take this path. And then you're putting all those traffic paths right here because you're not looking and maintaining the entire network for label distribution. You're just going on the edge and having traffic engineering simplified because now your controller says for voice, you're basically putting source routing right at the edge, so you're not concerned about anything because all the core is doing is just looking up the label and forwarding. So now your controller is saying for voice, take this route, for data, take this route, for Office 365, take this route. So now you don't have to go talk to each of the routers, thousands of routers in your core to make that decision or program them. you're programming them right at the edge. And that's how you are scaling. And that's how you are optimizing your network for multiple customer, multi-tenancy for service providers, and even very large networks. So that's a very super concept. So with segment routing, it's very easy to configure. It's just the concept that you need to kind of get it out. Why use segment routing versus traditional MPLS, LDP? Once you get a hang of that, configuring is always the easy part. For most IGPs, all you got to do is segment routing, but traffic engineering can be a little tricky from a configuration perspective, but nothing that super complicated. But again, the idea here was to understand what's happening, what is the difference between routing, MPLS, LDP, and then segment routing, and try to touch on those. So hopefully this helps. Appreciate it.